Good morning, everybody, and welcome to Math with Mr. W. Today, we're going to be talking about Pythagorean triples. A Pythagorean triple. And we've talked about Pythagorean theorem already, a squared plus b squared equals c squared. But this time, we're going to talk about the integers that work for them. And that's what a Pythagorean triple is. So, the lowest form of that is 3, 4, 5. And oddly enough, my father-in-law was a home builder, and he had a second grade education. Came from Canada, had a second grade education, and he knew two things about building homes. He knew 3, 4, 5, and he knew that water sought its own level. And with that, he could build homes with things being plumb and square, and they turned out to be beautiful. So we can make things square as well. We can get right angles whenever we want, because we know that 3 squared plus 4 squared has to equal 5 squared. And that's what we're talking about here. These are the lengths of the legs of the right triangle, 3 and 4, and 5 is the hypotenuse of that right triangle. And not only that, but any multiple of that is going to also be a right triangle. So if I choose 6, 10, I've got another right triangle, because 6 squared plus 8 squared, that's 100. And 10 squared is 100. So I've got another right triangle. So 6 and 8 are the lengths of my sides, and 10 is the length of the hypotenuse. So I've got these two, and I can make as many as I want, because I can multiply 3, 4, 5 by any amount I want. But what else are there? Well, I don't have any that start with 4. But I do have one that starts with 5. 5, 12, 13. 5, 12, 13. And of course, the multiples of that are exactly the same. So I have a 10, 24, 26. So if this works, then this has to work also as a Pythagorean triple. Now, if we keep going down this way, and let's start with thinking about odd numbers. Oddly enough, 6, 8, 10, yeah, we have one that starts with 6, but I'm going to think about the odd numbers. Odd numbers. Okay? 7. If I start this with 7, the next two sides that make up a Pythagorean triple are 24 and 25. Now, maybe you've got the idea and you found yourself a pattern that'll help you to figure out what happens when I start with 9. So this is the thing you ought to ask your students. See if they can figure out what the pattern is. And it's so elegant. And I know that they might say, well, see, 4 times 3 is 12. 12 doubled is 24. There's nothing seems to be here, but what if I, 4 times 3, 12 times 9. There doesn't seem to be anything. Let's see, 4. Well, let's see. 4 times 3, 4 times what? 4 times 6. 4 times 3, 4 times 6. So that they think about this and get them thinking about, is there a pattern? What will I put down for these two numbers? So maybe one will come up, they'll notice, ask them, what do you notice about these two numbers? Ah, they're one apart. That's right. They're one apart. Okay, so they're one apart. Now ask them, what's the sum of these two numbers? 9, 25, 49. 9, 25, 49. Those are my perfect squares. 3 squared, 5 squared. Oh, you're kidding me. Yeah, that's right. That's right. So if it's 9, this is going to be 40 and 41, because 9 squared is 81. The other two have to be 40 and 41 because they add up to 81. They're one apart and they add up to 81. What a beautiful pattern. And then there's any multiple of these. So there's an infinite number of triples that you can use, an infinite number of triples that you can use on all kinds of tests and quizzes that you can give your students and never have to worry about weird square roots and stuff as answers. And I think that's a great big help, because at this level, you might occasionally want to throw in the square root of 24. And maybe they have to simplify that to 2 root 6. But at this point, what are we trying to teach the student? Ask yourself, are they trying to really get them to simplify square roots, look it up on a calculator, or are they trying to get number sense about what that value is? What is the square root of 24? Well, it's a little bit less than 5, isn't it? Because the square root of 25 is 5, isn't it? So we're thinking about where that thing is. So this has got a beautiful pattern. So if you go to 11, 121, 11 squared is 121. What two numbers that are one apart and add up to 121? 60 and 61. And now you have another Pythagorean triple. Now, that's a great list of Pythagorean triples. And I hope you've got those down on a piece of paper. But now, let's add something, okay? Here's what I'd like you to do. Have your students try this. Even maybe you've got this already and you're doing it already, but this is a great way. How would you guys like to make a Pythagorean triple all the time? No matter what numbers you choose, I guarantee it's going to be a Pythagorean triple. And they're going to look at you. Okay, here's what you ask them to do. Choose two numbers. Now, you're going to ask them to be those two numbers that we're going to be in here. They're going to be less than or equal to 15 and greater than or equal to 0. That's it. Two numbers. Have them choose two numbers. Two integers, greater than or equal to 0 and less than or equal to 15. Okay, so let's call them A and B. So we'll call A the biggest one, and we'll make that guy 12. And we'll have the little guy be B, and B can be any number, and he's going to be 5. 12 and 5. So those are our two numbers. Now, here's what we're going to ask you to do. Okay, kids, here's what I'm going to ask you to do. I'm going to ask you to do 3 things. I'm going to ask you to take A squared plus B squared and figure out what that is. And then we're going to ask you to take out a squared minus b squared and figure out what that is. And then I'm going to ask you to figure out what 2 times a times b is. So they have 3 things they have to figure out. And now they're doing a little substitution. They're doing some adding. They're doing some things that are part of algebra. This is great little practice for them to do. Okay, so in comes the a squared, 144, plus b squared, plus 25. Well, that's 144, 54, 60, 169. Then we're going to do a squared minus b squared. So we're going to take 144 and we're going to subtract 25 from 144. So 144, we're going to subtract 25, and we're going to have a 9 here, and we're going to have a 1 here. So that's going to be 119. And then we're going to have 2 times a times b. So that's 5 times 12 is 60 times 2. 60 times 2 is 120. Wow. Wow. Is that right? 169. So these are the 2 smaller numbers. These are the legs, and this is the hypotenuse. So 119 and 120, these are the legs of my right triangle, and this is the hypotenuse. So now all you have to do is ask them to figure out if that works. Figure out if that works. So we can square, and I'm going to get out this because I don't know right off the top of my head what the square of 119 is. So I'm going to even figure that out myself. So 119 times 119 is 14,161 plus 120 squared. 120 squared, and that's 14,400. And that should equal the square of 169. What is the square of 169? 28,561. If I add these 2 together, son of a gun, 1 and 0 is 1, 6 and 0 is 6, 1 and 4 is 5. Ha ha! This side equals 28,561. Indeed. Therefore, these 3 numbers make a Pythagorean triple. So we've just made 1, 1, 9, 1, 2, 0, 1, 6, 9. It's a Pythagorean triple. Ta-da! It surprised myself. Now, you can choose any 2 numbers you wish. The bigger number has to be A, the smaller number has to be B. Follow the directions, and you'll create a Pythagorean triple. And with the infinite number of these that you have, of course, 13 is 169. And so that means half of that is going to be 84, 85. And so we get 84 and 85. So you've got an infinite number to choose from to make those quizzes and tests. You don't have to come up with really strange numbers. Use the right triangles and make them use the Pythagorean theorem, but don't make it so difficult that they can't solve for them. So I hope you've enjoyed this little visit to the Pythagorean theorem and right triangles and Pythagorean triples. I hope you use it. Have yourselves a great year, a great day, And I'll see you next time on Math with Mr. W.